Welcome back. In today's video lecture, we are going to discuss the reactions of alkane, in particular how the alkene is going to convert it into alcohol. So previously we discussed various reactions. The first reaction is hydrogenation, so that is syn addition. The second reaction is halogenation, that is anti-addition. And in that particular, so we have discussed halohydrin also, followed by the third reaction we discussed hydrohalogenation, both in the presence of peroxides and absence of peroxides. So there we discussed the carbocation stability, then free radical stability. Accordingly the product will get vary. So this we discussed. Please remember that I am teaching these reactions in certain sequence. If you learn in this sequence, it is very easy to remember. That's why I structured in this order, so that will be very easy to remember. Now here the hydration of alkene is one method. So convert alkene to alcohol. Okay, so in the presence of this, like acids, either we can use sulfuric acid or phosphoric acid. So this is a reversible reaction, and the shift of equilibrium mainly depends on the temperature and the strength of the acid we are using. For example, if you use the alkene with water in the presence of acid, at lower temperature we are getting alcohol. The same alcohol reacting with the sulfuric acid at higher temperature, we will get alkene and water. The alkene plus water is a addition reaction, that is alcohol. The formation of alcohol is addition reaction, and the formation of alkene from alcohol is a elimination reaction. Okay, that we will discuss in forthcoming classes. Now let us see how the alcohol is getting formed from the alkene. So this is as similar we learned in the hydrohalogenation reaction. The first step is the protonation. So the protonation can occur either of the alkene carbon. For example, suppose in this alkene carbon, the first carbon, so if it is get protonated here, so this carbon will get positive charge. You see, that's why I put it here, and this is a tertiary carbocation. Suppose if it is in the second carbon, then this will be the primary carbocation. Okay, so like this. So this is the primary carbocation, and this one is tertiary carbocation. As we learned, the tertiary carbocation is more stable than secondary than primary. Okay, so why this is most stable? Now the water, the oxygen lone pair will attack the carbocation, so we will get this intermediate. This oxygen positive charge is getting stabilized by losing this hydrogen lose its electron, and we will get this alcohol. Similarly, if this also possible, but this will not form in major amount. Why? Because this is least stable. Okay, this will not form in the major amount. Why? Because this primary carbocation is least stable. This will not form in the major amount. That's why this product will not form. Now we discuss one more problem. Now what will happen in this case? If you take this alkene the same way, what will, so it can get protonated. So if it get protonated here, so it will get CH3, and this will get, so this is what? A secondary carbocation. And another way, so in the another way, what we will get? If it gets in this carbon, this first carbon, this is alkene carbon, this second alkene carbon. Suppose if it is getting added to this one, so we will get the CH2, and we will get this one. So this is the primary carbocation, and this is the secondary carbocation. We may think that this water will come and attack, No, it's not possible here. This we already learned it in the last class in the hydrohalogenation. Wherever there is a possibility of that rearrangement of this carbocation, that can occur. You see, here there is an hydrogen, there is this shift, hydride shift can occur here like this. So we will get this one. So we will get this one. This is a tertiary carbocation. Okay. Now water will come and attack here. Finally we will get like this. Like this we will get. Okay. So this product we will get. This is the rearranged product we can get. The same thing here also. The product distribution or the formation is mainly mediated by the carbocation stability. So please remember that wherever there is a carbocation, please think, is there any possibility to get the most stable rearrangement carbocation? You see, this is the secondary and this is the tertiary. This is the most stable. That's why this will form in major amount. So this product will form as a major product. Okay. Now that's all about the reaction. Now I want to raise one question here. This acid, okay, why we should not in this use HCl? Mostly in the hydration of alkene, so we don't use this HCl. We preferably use either sulfuric acid or phosphoric acid. Why? That you can think it and find out. Okay, so you just find it out. I hope you understand this reaction. Kindly subscribe and share this lecture if it is useful. Thank you very much.